What we're seeing today along the east coast of the United States is not surprising. Sea level is rising. We're going to see storms and flooding move further inland.
Could climate change be fueling the history-making nature of this storm?
And create change along our coastlines. This region is vulnerable because the rate of sea level rise in the mid-Atlantic is among the highest in the world.
Changes in relative sea level can be driven by change in the ocean's elevation or change in the surface of the land. And we think both of these are happening in the mid-Atlantic.
Around the Delmarva Peninsula, it's not just our natural environments, but also people's homes are affected by flooding.
Sea levels could rise, making many places unlivable within 30 years.
Sea levels have risen about 12 inches in the last century.
People can see ghost forests, but they might not see that the water is becoming more saline. They might not see that the land is becoming flooded more often. Our systems are really changing. The adaptation measures that we take need to address the whole system and not just one aspect. Sea level rise and marsh migration is not a new process. It's been happening for thousands of years. The problem is that now the rate of change is happening very quickly. I became a hydrologist because I could see how the science that I was doing could benefit society. When I'm thinking about developing a new project, I want to make sure that the effort that I'm making is really going to benefit us, people around the world.
So
The register temperature.
So it takes 9 to 12 about.
We're studying the transition from marsh to upland in forested ecosystems and in agricultural ecosystems. The mid-Atlantic coastline is very low-lying, and so it's vulnerable to rapid change with changes in sea level and climate. In this project, we're seeing firsthand the consequences of saltwater intrusion. It's clear in all of our sites the effects of large storms and effects of longer timescale sea level rise.
To really understand this environment, the Chesapeake and the Delmarva, you really have to take a deep dive into history. 1.8 million years ago to roughly 12,000 years ago, you have ice sheets. So north of us, we've got these enormous ice sheets. It's really hard to comprehend. Ice a mile to 2 miles thick. That weight, it depresses the Earth's crust, but it bulges out at another part. This area in the Chesapeake was on the bulge. Around 12,000 years ago, there's a last gasp of the ice age and a cold snap, and from there on, it starts to warm. Ice sheets melt, sea levels rise, shorelines creep backwards. The Earth is starting to rebound, and here the Earth is settling. So in effect, we have about twice the rate of sea level change as we have globally.
So I'm Dennis Coker, Opsu Coenamuke, white otter of the Lenape Indian tribe of Delaware. Bombay Hook is an area that is very, very significant to our tribal community. My great-grandfather was actually born out here and lived here for much of his life. Prior to contact, these marshes sustained our people forever, harvesting foods, animals for pelts and skins and meat. The sea level has been rising for a long time, and we've adapted each and every time, but the rapid increase that we've experienced since the Industrial Revolution is just more than we can really handle in a short period of time. The problem that exists for us today, we are boxed in. We have nowhere to go now. Before, we would just retreat a little bit further inland. We can't go another half a mile west of here because we don't own the property. It's all in private hands. So that sea level rise certainly is impacting us today. You know, our only option is to pack up and leave, which is not what we want to do, since the source of our spirituality is right here. With warming temperatures creeping up from the south, we're getting closer to those megastorms. As these storms increase in frequency and increase in intensity, I do expect that we're going to have a major impact storm, and it could very well be devastating.
The most intense storms, categories 4 and 5, models show those increasing.
Climate change is causing increases both in the intensity of storms and also in their frequency. What used to be a 100-year storm is now a 10-year storm. If you think about those two together, storm surges and long time-scale sea level rise, these slow changes over time, coupled with these fast flooding events, are what stress the vegetation and eventually cause ecosystem change. If we want to develop effective strategies to mitigate the changes that are happening, we first have to understand what is happening and why.
I like to call saltwater intrusion the invisible flood because it's often far further inland than we think it is. As sea levels rise, it starts to drown out marshes, and the marsh, in turn, will start to move upland. And what's upland of a lot of our marshes? Forests. Those salts start to move into the tissues of the trees, and they can burn them from the inside out. And as they continue to move inland, you'll get a transition where you have marsh in the understory, and then you have your overstory of stressed and dying trees.
Areas where there was forest are now dramatically changed. You see like gray sentinels, these ghosts of trees. 20 years ago, when I visited, they were alive and they were flourishing.
We put our instrumentation in two different kinds of systems. Farms that are being affected by sea level rise and saltwater intrusion, and then forests.
In agricultural fields, we're seeing increases in salinity in the soils, and that is stressing the crops. When we first started doing this study, we set up our sites with transects from the marsh into the healthy ecosystem. By capturing that spatial transition, we would be able to use that as a surrogate for time. Over only a 5-year project, we don't expect to see a lot of ecosystem change. But what we've seen is that the change in some of the sites is happening so rapidly that we actually are capturing it in real time. The change is happening rapidly enough that one of our farms is no longer being actively farmed.
I got a big belly. Oh, look at your belly! Yay! Oh, that's so exciting. Congratulations.
Thank you. How are you?
So, are you drinking coffee?
I'm drinking tea, mainly.
Do you want some tea?
Yeah, that would be great.
Okay.
Marshes are really good at storing carbon in the soil. All of the decomposition processes slow down. And so all that carbon that's put in, dying plant material, roots, microbes, they take longer to decompose. This is the one that we apply a suction, so we suck all the air out of it, and then it fills with water. And that way we can measure what the water looks like at the 60 centimeters below the soil surface and see how salty it is, or if there's other nutrients in there like carbon or nitrogen or phosphorus.
The growing that the farmer's been doing has been less and less every year. I know he's up at the other end of the field, but last year there was nothing.
Yeah.
I mean, nothing grew.
And then he gave up this year.
He gave up, yeah. There's no more planting. So I don't know what would happen if it was in this part of the field. I've also noticed that there's more water coming in off the creek during storms and after storms.
Like over by the house,
Yeah,
right?
there's more water, it's coming in further, and we've never seen that before. But this tree, about just 2 or 3 years ago, started losing its leaves, and this year it has nothing.
I'm not surprised that this tree is struggling because it's so close to the creek here. Usually it starts from the bottom and then moves its way up to the top, kind of like they're being burned. I think saltwater intrusion and sea level rise has a huge impact on coastal properties because it's just untenable to try to continue to live in a place where you're constantly being bombarded by these large storms and these high tides.
Coastal communities face a lot of challenges. They have to figure out how to deal with the changes that they're seeing now, increases in flooding, for example, and also anticipate changes that may occur in the future and figure out how to mitigate that for future generations.
My role really is to manage the government operations of the town. It's kind of morphed because of the issues that everybody's having to address. A lot of people come in and say, the street floods all the time and you need to find a solution. We run between 2 and 10 feet above base flood elevation, so we have instant impacts as soon as rain starts to fall or the tides start to go up. It became important to try to identify things that we needed to do right away and then also identify things that we could do now or plan for now that would help in the future. That's what they use to determine what the base flood elevation is for a specific place. The flood protection elevation is FEMA language and adopted by Oxford that tells you how high the first floor of a house has to be or a structure has to be. So in Oxford, we have 3 foot above what FEMA says is your base flood. Well, you're still looking at them expecting in 2100 for the water to be close to what we're building to today, which seems, wow, we'd be okay as long as there's no waves.
Right, no storms.
No high tides.
No 6 inches of rain.
And yeah, so in my opinion, and I think that's a recommendation we come forward with to the commissioners at some point, is that we at least require all homes in Oxford to be built to be 8 foot.
Either that or you lose your house.
So the way Oxford adapts to these future risks, short-term, long-term, is just incrementally, right? They're saying 1 foot in 30 years. Well, what if they're wrong? What if it's 2 feet in 30 years and you only planned for 1? But we don't know when that's going to happen, you know? Could be 100 years, could be 200 years. Could never happen. I think we're all committed to fighting to the point where it's reasonable. A lot of towns are just not even worrying about it. They're just not even, they're just going to retreat. They're not going to bother trying to fight. I worry about that doomsday glacier breaking loose and, all of a sudden the sea rises 10 feet like in a day. If it did, that would change everyone's planning.
It is human nature to figure out the solution. Well, it may not look exactly like it does today, but planning puts you in a better position than just waiting to see what happens.
This is a hard problem. It's a problem that's not going away. It's a problem that affects different communities in different ways. So we're going to have to work together as communities and scientists and engineers to figure out what the best way to move forward is and what the best way to mitigate what these changes in the future are. This project allows us to understand the processes that are causing changes along our coastline. Those changes are important economically in terms of impacts on agriculture, but also important to the services that our ecosystems provide.
In some ways, what we're seeing is nature trying to reclaim her space. A lot of these farms were once marshes. The research that we're doing can help farmers now that then could have really important consequences both for their bottom line but also for ecosystems. Some farmers really want to keep practicing agriculture. There are certain strategies or maybe certain crops they could plant to achieve that goal of keeping the land in agriculture. But then you might work with someone like Betty. She wants to think about the kinds of species that might bring the butterflies and the dragonflies and the birds back.
My hope is that we can preserve the land as well as possible. Just whatever is good for the environment, whatever's good for preservation of this area.
Are you worried about the future of the farm and this land? Because I know you had talked about wanting your granddaughter Sophia to maybe inherit the property one day.
I'm a little concerned about the house. In my lifetime, am I going to see it? I don't know. But Sophia said, well, I think I want to live here full time and have horses in the field. So that's...
So we can turn it into a horse pasture with a beautiful meadow.
So maybe we should plant part meadow with flowers.
Okay.
I really want to see this planet thrive.
There's a lot of data that show that letting nature take her course here is actually some of the best ways that we can take carbon dioxide out of the atmosphere and then store it.
And the marsh is a wonderful ecosystem.
It is.
Yeah, so I'd like to see that preserved.
The CZN is the network of scientists and scientific groups that are investigating different critical zones all around the United States. And so there's some in the mountains, and there's some in the plains. In our study, we're focusing on the eastern shore of Maryland, Delaware, and Virginia. The project was funded by the National Science Foundation in 2019, and the project is going to run for 5 years. The Coastal Critical Zone Project has 4 main research threads: hydrology, biogeochemistry, ecology, and then geomorphology. All of these systems are coupled. You can't understand something as complex as the coastal critical zone unless you're looking at it from all different perspectives. So I'm working with the biogeochemistry, and my two other co-PIs for that project are Dr. Yo Chin and Dr. Angelia Seiferth. On the hydrology side, we have Dr. Holly Michael and Dr. Sergio Ferragazzi. In the ecology sector, we have Dr. Karen Gadan and Dr. Stephanie Stotz. And then in the geomorphology thread of the project, that's being led by Dr. Matt Kerwin, and he's looking at how the landform is changing as a result of sea level rise and saltwater intrusion.
Teamwork among different scientists in different disciplines is critical to a project like this because the system that we're working in is very complex. The geomorphology, or the land surface elevation, and the hydrology are going to determine whether flooding happens. Whether flooding happens will determine the salinity. The salinity of the soil is going to affect the carbon in that soil and whether the carbon is released. The salt will also affect the plants, as will the flooding itself. And when plants die off, their roots may collapse, and that may cause the land surface elevation to decline, which is a positive feedback on flooding, right? So then more flooding occurs, more salinization occurs, the water table becomes higher. It's only by understanding how the system as a whole works that we can understand how it will change in the future.
I do think that at larger scales, the kind of data that we are acquiring in this project could be used to help parameterize some of these larger carbon models, biogeochemical models, to help us understand better this coastal critical zone and its influence on climate change.